Okay, Assalamualaikum and good afternoon. Alright, so let's continue our tutorial by question number 7. Alright, so for this question, okay, we are talking about the same thing, which is the Newton's second law, isn't it? But now we have two different bodies. As I told you before, by having two different bodies, we need to separate these two bodies. Okay, so I just separate these two bodies first, and then we just label it by body 1 and body 2. Of course, this is the way how to answer the question. Okay, so now please refer to the question. Figure 4 shows a 5 kilogram box placed on a frictionless horizontal table is connected to a 9 kilogram hanging box by a string that passes over a pulley. Okay, so the mass of body 1 and body 2 given already as 5 kilogram and 9 kilogram. So draw a free body diagram of both boxes. So as I told you before, we need to separate these two bodies. Okay, determine the magnitude of the acceleration of both boxes and determine the magnitude of the tension in the string. Okay, so now according to this question, they ask you to find first, they ask you to draw a free body diagram. Second, they ask you to find the acceleration, means that the object is moving now. Okay, and then at last they ask you to find the tension that exerted on the string. Okay, so now we just refer to each body one by one. We just start by the first body. How many forces exerted on this body? Okay, the first another keyword given here is frictionless, means that there is no friction between our touching surface here, which is between the box and the table here. All right, no friction. Okay, so based on this, for any frictionless table or surfaces, okay, so we are talking about how many forces now exerted on the first body. Okay, let's start by first. Of course, we have weight, isn't it? That one is weight of the first body. We label it as W1. Okay, by having weight, then it just push the table. The table just react again with the normal force, isn't it? That one is N1. All right, and then the body also connected to a string. Okay, so the reaction force exerted now just on the string, which is the tension. So remember, the tension should be directed out of body. So this is the body, out of body should be directed to the right lah. Tension. And let's say T1, we just assume it as T1. Tension exerted on body 1 lah. Okay, and then there is no friction, so we just ignore it. Okay, so this is the force exerted on body 1, which is N1, T1, and W1. And then it just pulled by the second body here. Of course, the object is moving to the right, isn't it? So that one is the acceleration. Okay, I just put A here to show the motion and the direction of motion, so you may know which force is positive, also negative. Okay, so acceleration is not a force, so we just sketch it out of the axis lah. Later I'll show you in the free body diagrams. Okay, and then for the second body, what do we have? Okay, this is our second body, so we still have the weight here. That one is W2. All right, and then also the tension directed out of body. This is the body out of body, so that our T should be directed upwards. That one is T2, out of body. Or in simple words, the tension just directed towards the pulley. See, this is the body towards the pulley, or this is the body and the tension just towards the pulley, or maybe just directed out of body, out of body, keluar dari jasad. Okay, so this is the way. That one is the tension. Okay, and then of course the acceleration is downward lah. The second body just pull the first body here. They are moving together because they are connected to each other using a string, isn't it? Okay, so now by connecting a string, then the acceleration should be the same lah. They are connected to each other. By having different acceleration, what happened? The string putus, broken already here, is it? Okay, so snap already here. So for this case, A still the same, so that the tension also the same. We take it as tension only. Tension. So in this case, tension equals to tension, or acceleration equals to acceleration. So in this case, from the first body, we have two equations. which is from the x-axis, also from the y-axis. And then from the second body, seems like everything just lay on the y component, so that we just have one equation only, which is from the y component. So two equations and one equation, we have three different equations there. So when t equals to t or a equals to a, normally under simultaneous, then we may answer the question. Okay, so by having this, and then we just sketch the free body diagram. So this is the free body diagram getting from the first body and from the second body. Okay, so the tension just directed to the right, the normal force, weight, and this is the acceleration. See, don't put this arrow on the axis, because acceleration is not a force. Okay, so we just separate it. So we have three forces only, which is N1, T, and W1. And then for the second body, what do we have? Okay, two forces there, which is T and W2, and this is the acceleration again. Letak luar, jangan letak dalam. We need to separate the acceleration. I just put the acceleration here because easier for us to know which force is positive and negative later. Okay, alright. So from this is the free body diagram. Remember, it must complete with the arrow. Without the arrow, it's wrong. Okay, alright. So by having the free body diagrams, okay, now from the first body diagram, the acceleration now just lay on the x component, isn't it? So Fx equals to m1a. We are talking about the first body, which is m1 lah. Okay, so Fx equals to m1a. So on x component, what do we have? Just the tension only, isn't it? So tension, total of force is tension, equals to m1a. So m1 given already, which is 5 kilograms, so that you will get T equals to 5a. So this is the first equation getting from the x component from the first body. Alright, and then from the y component, seems like there is no motion on y. It doesn't jump, dia tak melompat kan. Okay, so no motion on y, so that sum of Fy equals to 0. It doesn't move on y component. So as usual, upward is positive and downward is negative. So that the equation is N1 plus negative W1 equals to 0. Okay, so you will get this N1 plus negative W1 equal to 0. So that N1 equals to W1, where W1 is the weight of the first body, which is M1G. So M1 given already, which is 5 kilogram, and G is 9.81, which is our constant. Alright, so that you will get N1. N1 equals to 49.05 Newton. Okay, leave it. Okay, I think we don't have to use these values, leave it first. Okay, and then we just refer to the second body. From the second free body diagrams, okay, seems like everything just lay on the y component, isn't it? So we just start by the summation of Fy lah. Okay, and we got A here. So sum of Fy equals to M2A. So we label it as M2. To avoid any confusion here. This is M1 and this is M2. So based on this, A is directed downward. So for any downward force, it becomes positive. So Wx plus negative T equals to MA. T should be negative because T just against the motion. Okay, so W2 minus plus delta negative T equals to M2A. So that W2 is M2G. Okay, minus T equals to M2A. So M given already, which is 9 kilogram, the mass of the second body. Again, G just a constant. So that M2 given is 9. So that you will get this equation. So this is equation 2, getting from the second body. Okay, so as I told you before, T equals to T, isn't it? So by having simultaneous between equation 1 and equation 2, we just substitute T equal to 5A into the second equation for this T. Sub 1 sub into 2. Okay, so that you will get 88.29 minus T equals to 5A, substitute here, and then equals to 9A, so that you will get the acceleration. Okay, so the acceleration is the third things. So these values we just substitute into the first equation here. By getting A, substitute into the first equation here, and then you will get the tension. Okay, so third sub into the first one, and then you will get the tension. Okay, so this is the way how do we answer the question. Normally under simultaneous, then you will get the answer. Okay, alright, so remember, for me, I like to draw the free body diagram first separately, and then from each free body diagram, we just take out the main equation from the x component, also from the y component. From that equations, then you may see which equation should be combined now. Okay, so I like to numbering the equation lah. From the exponent, equation 1, and then from the y maybe equation 2, and then equation 3, you will get the fourth one, and then sub into the first one, you will get the fifth one, something like that. I like to use numbering system. Easier for you to understand the step. Okay, alright. Now, for question number 8, still same. Two bodies given here, which is P and Q. Alright, so according to the question, figure 5 shows a stationary block P tied to a hanging block Q. The weight of block P is 25 newtons and the coefficient of static friction between block P and the horizontal surface is 0.4. Assume the pulley is smooth, okay, no friction on the pulley, and the string is light. Okay, so the mass can be ignored, so that the tension just be the same lah, based on these two assumption. Okay, pulley is smooth and the string is light, so normally there is no friction on the string, then the mass can be ignored, so that we just assume that the tension for both parts just equal to each other. And then they ask you to sketch a free body diagram, okay, of block P, and then calculate the mass of block Q. Okay, seems like in this case they ask you to sketch a free body diagram for P only, but to calculate the mass of Q, again we need to sketch a free body diagram too, because we need to take out the equation, isn't it? Okay, so we just sketch a free body diagram for both object. Doesn't matter. Okay, because to answer question B here, we need to refer to the free body diagram of Q. Okay, so what info do we have here? Okay, this is weight, it's not mass. Please check the unit, Newton, weight. Okay, that one is WP. It's not MP, WP. And then coefficient of static friction, that one is mu S. And the info given is static friction, means that the object doesn't move, so there is no acceleration. Okay, so I just take note here, A equals to 0, A equal to 0, it doesn't move. Okay, that is why in that question they don't ask you to calculate the acceleration, because it doesn't move. Okay, so again for this we have two different bodies. We need to separate these two bodies again. Okay, and then we just determine all the forces exerted on the first body, which is P. What do we have? WP. And then normal on P. And then the tension out of body, that one is tension. And don't forget about the friction, static friction, Fs. Okay, alright, and then on the second body, what do we have? Still the same, weight of Q. Weight of Q, also the tension. Okay, so by having this, and then we just transfer all the forces to be on the axis, and we need to combine all the forces now. So this is the free body diagram that we have for P and Q. On P, what do we have? Just normal force, weight, tension, and this one is static, Fs, static frictional force, because it doesn't move. Okay, and then for Q, what do we have? Just tension and W of Q. Okay, so from this, alright, so they ask you to sketch. Okay, complete already. Remember, all the forces should be come with the head, the arrow here, head of the arrow. Make sure that if not, some mark deducted for the diagram. Okay, and then how to calculate the mass of Q? Okay, so from this we have two different axes here, so that we need to take out the equation from the x component, also from the y component. And for the Q1, seems like everything just on y component, so we just have one equation which is on y component only. Okay, alright, so from P, sum of Fx equals to 0, right? It doesn't move because we are talking about static frictional force, isn't it? So in this case, to the right is positive, to the left is negative. So T plus negative Fs, or T minus Fs equals to 0. then T equals to Fs. It's not Fk, sorry, my mistake. Fs. Static frictional force. Okay, and then T equals to mu n. Which n is that? N of P lah, because we are talking about the first body, which is P. Okay, so mu given already, which is 0.4. So that you will get the first equation, which is tension equal to 0.4 n of P. First equation. And then from the y component, sum of Fy equal to 0. Upward is positive, downward is negative, isn't it? Because we don't have any motion here. So Np plus negative Wp, or Np minus Wp equals to 0. So sum of Fy equal to 0. So Np minus Wp equal to 0. Then you will get Np equal to Wp, where Wp given already, which is equal to 25 Newton. And remember, weight given already, because the unit is Newton. Okay, so this is normal force on P. Second equation. Okay, leave it first. Second value is getting there. And then from the second body, which is Q, okay, again no motion, so T is positive while WQ is negative because downward direction. Okay, so sum of Fy equal to 0, T plus negative WQ, or T minus WQ equal to 0, so that T equals to WQ, where WQ is mg, isn't it? Which m? mq lah, because we are talking about the weight of Q, isn't it? Weight of Q is mqg. Alright, so that tension equals to mqg. This is the fourth equation. Okay, according to this, tension equals to tension. Okay, remember that. But before that, we just, okay. Okay, now we got the third equation already. We have calculated T before, isn't it? From the third equation here, which is T equals to 10 Newton. Okay, sorry, before that. Okay, this is NP. NP calculated before already. So, substitute into the first equation. Sorry. Second, sub into the first one. We just sub NP into this equation, and then you will get the tension, isn't it? So the tension calculated already, which is 10 Newton. By getting the tension here, the third equation, we just sub into the fourth equation before. And because the tension calculated just now, 10 Newton, substitute here, G just a constant, so that you will get the mass of Q directly, which is 1.02 kilogram. Okay, again, using this numbering system, easier for you to understand the step. Okay, alright, so this is my suggestion lah, how to answer the question. Okay, next, number 9, still the same, two bodies connected to each other using a string. Okay, first we need to check, are they moving or static? Okay, so read the question. Figure 6 shows a 2.5 kilogram. Okay, this is, okay, the first body, which is, okay, I like to numbering the body. First body and the second body. Okay, so that the mass of the first body given already, which is 2.5 kilogram, connected to a 2 kilogram, this is the mass of the second body. Okay, by a light string again. Okay, so light string, the mass can be ignored through a pulley of negligible mass. Again, the mass also can be ignored. The pulley can be ignored. Means that the tension at both sides just the same. Okay, the coefficient of kinetic friction. This is the keyword. By talking about kinetic friction, so the object is moving. Okay, and the table. Okay, so the values given is coefficient of kinetic friction, so that one is mu k. Alright, mu k is given, which is 0.18. So by talking about kinetic, the object is moving lah. So when the system is released, calculate the acceleration. That's why they ask you to calculate the acceleration, also the tension. Okay, alright, so by releasing the second body, which is hanging now, seems like the object just moving downward, isn't it? So this is the motion, A. So the first one just move to the right lah, also A. Okay, so again, two bodies involved, then we need to separate these two bodies. Separate first. Okay, then what force exerted on each body? Okay, so what do we have? The first one is W1 also, N1, and then out of body should be the tension, and then friction. Remember, kinetic friction Fk, because the body is moving now. Okay, so this is the force exerted on the first body, and then on the second body, what do we have? Just W2, weight of the second body, and out of body is the tension again. And remember, the tension are the same because the mass of the string can be ignored. Also the pulley, there is no friction. Alright, so the tension can be just the same. And also the acceleration. The friction on the pulley is not the friction by the body on the pulley can be ignored. So this is the keyword. When the pulley is massless, when the string is massless, or the pulley is frictionless, okay, seems like the tension just equal to each other lah. Okay. Alright, so by having this, again, we just take out the free body diagram, and then again, by having the equation from the x component, y component, also y component here, three of it, and then we just combine it, and then you will get the answer, which is acceleration and tension. Okay, so this is the free body diagram from the first body, also from the second body. On the first body, what do we have? Weight of the first body, normal on the first body, the tension, also the friction. Alright, and this is the acceleration. Again, I just separate the acceleration because acceleration is not a force. Okay, I just put outside there. Okay, and then for the second body, what do we have? Weight of the second body, the tension, also its motion, which is acceleration A. Okay, so from the first body, from the x component, seems like A just lay on the x component, so sum of fx equals to m1a. We got A on x component, isn't it? So again, A just directed to the right, so to the right force is positive, to the left is negative, so T plus negative Fk or T minus Fk equals to m1a. Okay, where Fk equals to mu n1, because we are talking about the first body. F is mu n, so which n is that? N of the first body lah, which is n1. Okay, so by having this, T minus mu n equals to m1a, m given, mu given already, which is 0.18, so that you will get this equation. So this is our first equation, where T minus 0.18 n1 equals to mass of the first body given is 2.5, okay, multiplied by a. So this is the first equation. And then from the y component, it doesn't move on y, it doesn't jump, isn't it? Okay, so n1 is positive upward, while w1 is negative because directed downwards, isn't it? So sum of fy equals to 0 equals to n1 plus negative w1, or n1 minus w1 equals to 0. So that n1 equals to w1. W1 equals to mg, which m1 lah, because we are talking about the weight of the first body. So m1g, m1 given already, which is 2.5 kilogram, g just a constant, so that you will get the values of n1. N1 is 24.53 Newton. Okay, we label it as second equation or info lah. Okay, so and then we just refer to the third, second free body diagram. So take out the third equation. Okay, everything just on y component. Again, A is downward, so downward force is positive, upward force is negative because it's just against the motion, isn't it? Okay, so in this case, sum of Fy equals to MA, so which M2 lah, because we are talking about the second body. So in this case, W2 minus T equals to M2A. Okay, so W2 is mg, m given is 2 kilogram, g just a constant, minus T equals to m2 is 2, and then a. Okay, so that you will get the the fourth equation. Okay, this is the fourth equation, which is 19.62 minus T equals to 2a. Okay, before that, by getting equation 1 and equation 2, this is n1. N1 can be substituted into the first equation, isn't it? Because this is N1. By getting N1, we just substitute into the second equation. Okay, so sub 2 into 1, so that you will get the third equation. T minus 0.8, okay, this is N1 calculated before, substitute into this equation, equal to 2.5a, so that you will get this equation. So this is our third equation. Tension equal to 2.5a plus 4.41. By combining equation 1 and equation 2, so that you will get the third one. And then from the second body before, we have deduced the fourth equation from the y component here. So by having equation 3 and 4, remember, T equals to T, isn't it? So we just sub and the third equation here, T, into equation 4 before. T here. Okay, so sub 3 into 4. So this is T equation from equation 3. Substitute into equation 4 so that you will get the acceleration, which is the fifth one. By getting acceleration, and then we just sub, okay, fifth into the third one. Which one? This one. By getting A, substitute into this equation, and then you will get the tension again. So this is the way how do we answer the question. Okay, so again, using numbering system, I think it's quite clear for you to understand the step one by one. So this is my suggestion how to answer the question. Alright, we just start by the free body diagrams, and then we just take out the equation from the X component, also the Y component of the first body, also from the Y component of the second body. So by having that three equation using numbering system, and then you just combine all the equation. That one is under simultaneous. Okay, so this is the way. Alright, so any problem you may ask me, okay, later. Okay, and lastly for question number 10. Okay, what is the question? Okay, what do we have? Just one body here. Figure 7 shows a 500 Newton force Fx on a stationary 25 kilogram box lying on a rough surface. After 4 seconds, the speed of the box is 2 meters per second. Calculate the frictional force on the box and the coefficient of kinetic friction between the box and the rough surface. Again, kinetic means that the object is moving now. Okay, so what info do we have first? Okay, let's check. The force given already, where the force is 500 Newton. Okay, X on stationary means that the object start from rest, so U equals to 0. At T equals to 0 initially. Okay, the mass given, mass is 25 kilogram. Alright, and then after 4 seconds, at T equal to 4, the speed V is given now, which is 2 meters per second. Okay, calculate the frictional force. They ask you to calculate the frictional force. That one is Fk lah, because the object is moving. What is Fk? Kinetic frictional force. And then the coefficient of kinetic friction. So they ask you to find mu s. Mu k, kinetic. Alright. Okay, so how is it? Okay, first I want to show you by having this. Seems like we may calculate the acceleration, isn't it? So we need to calculate the acceleration first, using linear motion equation, which is Voigt or Sutat. Okay, by getting the acceleration, and then based on the free body diagram later, and then we just calculate everything needed here lah. Okay, so let's identify what force do we have. This is the applied force, which is our external force, 500 Newton at 50 degrees from the horizontal. Next, what do we have? Just weight of the object. Also the normal force. Okay, by pushing the force to be like this, in this direction, the motion of course is just directed to the right, isn't it? That one is our A. And because the object is located on the floor, so by pushing at this angle, the object is moving to the right, isn't it? So this is the acceleration. By having this acceleration, then the friction should be directed to the left. That one is our Fk. Okay. Alright, so how to answer this question? Okay, first we just take out the by having this info, this is the info. At T0, U is 0, initial speed 0. At 4 seconds, the speed is 2 meters per second. Using Voigt, then we may calculate the acceleration. V given is 2, U is 0. Then at 4 seconds, the acceleration is 0.5 meters per second squared. So, and then we just draw a free body diagram. Okay, remember, don't forget some tricks there. This is N, this is W, this is friction transfer to be, make sure that the tail of the vector should be located at the origin, okay? And then also for this is the head actually, and this is the tail. The tail should be positioned at the origin. So I need to transfer the force, then the free body diagram just be like this. This is the force applied, so the tails should be positioned at the origin also for the friction. So this is normal force, this is the weight, and this is the force applied involving X and Y component, and this is the friction which is really on the X component. Okay, so based on this, seems like on y, on x, combination of x and y, so that we need to resolve f to be fx also fy. And where fx touched by the angle should be in cos, and y just in sine lah. It doesn't touch by the angle, isn't it? Okay, so for this, from the x component, alright, so the motion is really on x component based on this situation. So on x, A just directed to the right, so any force to the right direction now we take it as positive, to the left direction we take it as negative. Okay, so on x component, sum of fx equals to ma, so on x component, fx minus fk equals to ma. Fx minus fk equals to ma. Alright, so fx is f cos theta, isn't it? Because touched by the angle, fx is f cos theta, so f given is 500 cos 50 minus friction equals to mass given is 25 and acceleration calculated before is 0.5, so that you will get the friction, which is 308.89 Newton. Okay, and then from the y component, there is no motion, it doesn't jump there, so upward is positive, downward is negative, so sum of fy equals to 0, which is n minus w equals to 0. Sorry, we have three different forces. Sorry, first n, second w, the third one is fy. Don't forget that. We need to resolve f, isn't it? So positive, negative, and negative. So n minus w minus fy equals to 0. Where fy, okay, leave it first. So n equals to w plus fy. W is 500 times g, mg. This is mass times g, which is a constant, and fy is f sine theta. So f is 500, sine theta is 50, so that you will get n equals to 628.27. This is the normal force. By getting the normal force, by getting the friction, we know that the coefficient of friction is mu n, isn't it? So Fk equals to mu kn. We are using k because the object is moving. That one is under kinetic, okay? So kinetic frictional force equals to coefficient of kinetic friction multiplied by the normal force. Alright, so Fk calculated before and also calculated before, substitute into this equation, then you may calculate mu, which is 0.49. Alright, so this is the way how to answer the question. Okay, so I think enough for this chapter. So any problem, you may ask me through the Telegram groups, okay? Or try to compare the answer first. So for any confusion, you may ask me directly. Okay. Alright, so I think that's all for today. So see you again. Thank you. Assalamualaikum.